more categories. So the next level of analysis you can do once you develop the baseline, whatever, and then try to start finding out where your projects might lie, is energy audits. 3 different basic kinds of audits. There's the walkthrough that you can do all by yourself, without any help at all. A standard audit you may tackle yourself if you have a more sophisticated maintenance staff, some maintenance staff that has some instrumentation thing. You may want to involve that, but more likely it's going to involve the utility company, and this is something that the utility companies used to all offer for free of charge, and I don't know what the status of that is right now, but you could check with your individual utility company. I know they don't offer it to us at all, so I don't know whether Progress is doing that or who the other utilities are. But and then the third most comprehensive is the investment grade, and that's goes back to what I was talking about when you have an energy services company come into your organization and do what's called performance contracting. That would be required by any kind of investment into energy efficiency to make sure that it is done, that it can be backed up and it's going to actually realize the results that they're predicting. And that involves computer simulation as well. Now we're using the computer simulation on our new buildings. We're forcing the architects and engineers to develop these models that we can use once we take over the building, but we haven't gotten there yet on the existing buildings, and it's something that I want to get to, but we just don't have the time yet for it. So this is going to tell you where your energy is going. It's going to allow you to dig a little bit deeper into those different components and try to justify whether that's a proper use of that energy, whether you're getting the benefit of that or whether it's just waste and we can eliminate some of that. And finally, what can be done? Hopefully, through this process, you identify those energy conservation opportunities that we talked about, and you prioritize those, like I said. So again, this is too much. I got to take this one out. But 40% HVAC, 34 lighting, and 26 for everything else. That's pretty standard in a commercial building in Central Florida. The walkthrough audit. What do you need? How do you get going with that? Start with the billing data, like we talked about. Again, I'm going to say it again. Get 24 months of data. Get it into something like Excel that you can produce some graphs. I would do both the Energy Star and the Excel myself because you can really manipulate the Excel once you get it in there, and you can play a lot of scenarios on there, and real quickly and understand what's going on. If you've got somebody that's real savvy with Excel, it's pretty easy to do. This is going to identify your low-cost, no-cost opportunities a lot of times. And what we're looking for a lot of times is we're walking the facility, we're looking for equipment running that's not supposed to be running. We're looking for O&M, whether that's happening or not, whether the equipment's being maintained. People think about the HVAC equipment as being, primarily what needs to be maintained in a commercial building, but actually lighting can be maintained as well. And I can't say we're doing it at the university, but I have seen organizations do it where they clean lenses and they clean reflectors and things like that to make the light output greater from facilities. And that allows you to cut back on the amount of energy intensity of that product if you have that option in there. And then behavior changes. That's again what we call energy conservation versus energy efficiency. And we're doing a number of things at UCF there. Right now we have a student competition going on between the dorm rooms or whatever to see who can lower their energy use the most. So we promote that and we end up giving them scholarship money actually for the winning buildings kind of thing. So somehow that idea could be taken to the commercial environment, I think. And you've got various departments in a building, maybe they can compete against each other if you could find out if somehow you could meter it, or even if you can't meter it, maybe you can do a continuous audit where you're looking for people leaving their lights on or leaving things on, or looking at the positive instead of the negative, maybe, to look at rewarding people for good behaviors. But I think that same kind of idea could be taken to any organization if you just think it out a little bit. Now, preliminary work, I said again, you want to collect 2 years of data, you want to start analyzing that. You want to obtain some kind of drawings of the building. What I like to start with is a floor plan, and I like to make like 10 or 15 copies of that thing before I go out, because I'm going to mark them up. I'm going to use one of them for lighting, I'm going to use one of them for HVAC, and the HVAC is not going to all fit on there. I'm just going to note things as I go through the building. I'm going to look for inconsistencies in the building, how equipment's running, how equipment's being maintained, and I want to make notes of that. And maybe oversized equipment and things like that, or spaces have changed. That's something we run into a lot at UCF, is is that we're constantly moving people out of one area and into another area, and what they do actually changes, and their density of people changes, and so equipment changes need to take place, but they don't always take place at the right time or the right way. And so we end up finding a lot of those things when we go out in the building, and some of those are really energy intensive type things. We find out the equipment is way oversized for the heat load that's there now, or vice versa. With this energy data we're collecting, we like to compute this thing, and it's kind of the basis of the portfolio manager, is to compute this thing called EUI, and it stands for Energy Utilization Index. And what that is we take all the different kinds of energy in the building. You may have gas going into it as well as electric. In our case, we have chilled water going in the building as well. So we take all those energy sources and we make them the same kind of units, which involves a conversion factor. And those conversion factors are published on the web, real easy to find. And once you get them all in the same units, you add them all together and divide by the number of square foot. And so that gives us an energy per square foot. Then we can compare it to other buildings you might have in your same portfolio. You may have several buildings and they may be similar. Even if they're different sizes though, now you can compare that number if they have the same kind of use. But Energy Star really uses that number that's what they use to compare all the buildings all over the country with. So that's how your score is generated on Energy Star. So I encourage you to compute that and then start looking, and there's a lot of stuff on the web besides Energy Star that you can compare it to as well. So you can actually search for typical grocery store, whatever number in the southeast kind of thing, and you'll find numbers like that, and you can compare yours to it. Tools you might need for this walk-around audit are either one of the first two levels. Things I like to have is tape measure, light meter, power meter. Some of this stuff you're going to need some training to get. You're not going to want to tackle open electrical panels unless you have a trained electrician, obviously, with you. But a lot of your facilities have those kind of people on staff. So if you do, you want to get in there and you want to actually measure some of that equipment. Thermometer, anybody can operate. An anemometer shows us how much airflow, what the speed of the airflow is. It kind of helps us diagnose some of the airflow issues in the building on the air side. A notebook's key to keep notes as you go around. I really like, my favorite tool is a camera to be able to take pictures of everything, and I write down the picture number next to my note, and then I've got, I can build a report when I get back to the office kind of thing real easily. Now you're going to go out in the building and first thing I like to do is talk to the facility people, talk to the people that are on the ground in the trenches that deal with the building every day, and I tell them I'm there to try to reduce the energy cost. And 9 times out of 10 they go, oh, let me show you this. And we get up and go out to the closet right away and they go, this is our problem right here. And they find it, they know about it already, but they didn't know what to do about it. So they're very enlightening. So I really encourage you to work with the O&M staff in the buildings. They really know a lot of stuff and about how the building's been operating. Or they might know the opposite, that this is our problem. This is where we're not using enough energy. This is a real problem for the building, and we've got a lot of unhappy occupants here. Recording power consumption, that goes back to if you're able to operate those meters. Recording light levels is something we do a lot of, and I really recommend this to you. A lot of people are, think of lighting retrofits as low-hanging fruit out there, which it is in one respect, and we've had a lot of success with lighting retrofits at UCF. But we do it a little bit different. We don't, like if we're going to go into this space, there's a lot of companies out there you can hire to do lighting retrofits. They'll go in and they'll say, we've got 18 fixtures, we're going to need this many lamps, this many ballasts, and they give you a price and they go in and knock it out. And they're actually very competitively priced. They're very much set up for that kind of thing, and they can be, do it very inexpensively. But what we do differently is we actually measure the light levels in every one of the spaces, no matter how many little bitty offices we've got, and we compare them to what's the standards for the industry. And in this case, it's called the IES. It stands for Illumination Engineering Society. They publish standards for all different kinds of spaces and all different kinds of tasks taking place in the space. So if you're in an office, you have a big range, but depending on what you're doing in the office, whether you're doing like detailed accounting work, then you need maybe more light. If you're looking at a computer all day, then you need a different light level. So these guys publish all that stuff. So we compare our existing light levels with that list before we do the retrofit to make sure we don't overlight it. And we find out probably 70% of our spaces are overlit at the university. So we end up de-lamping at the same time we're doing a lighting retrofit. So we save both ways. We save by more efficient, and we also save by less lighting in the space. And our occupants are actually very happy with the results because they have less eye strain from the process. Post, after you get done with your walkthrough audit, you're going to go back to your office. You're going to, like a lot of times, you're going to be asked to prepare a report to prioritize these things. So that's when the pictures and the notes really come in handy. So we spend some time trying to put a good report that management can use to really understand what they think what you think the opportunities are in the building. Real-time monitoring. This again is something we created at UCF, and it's actually an open source project. Anyone ever heard of open source software projects? That means that they're freely available to use by anyone. So we give this software away, and this is an actual real screenshot from one of our buildings. This is one of the engineering buildings, and this is the chilled water usage in the building. So each one of these bars, this is a 24-hour graph, so each bar is 1 hour in the life of the building. So on this hour at 9 a.m., we were using 100-ton hours during that average period, or you can look at it as 100 tons of refrigeration capacity. The red line is the outside air temperature. Remember how I kept saying we relate everything back to outside air temperature? That's what we are always looking at for a correlation. And you can see we have a real nice correlation here on this graph, with the exception of 7 and 8 a.m. there on the end. Anyone know what might be happening at 7, 8 a.m.? Why would we have those spikes up? Yeah, it's probably a schedule thing, right? I mean, the building's becoming occupied. It's got an automation system in it, and the schedule's saying that it's almost time for class to start. We need to go from an unoccupied set point to an occupied set point. So at that time, this was probably, I don't have the date there, but it must have been some kind of winter day when it banged on the electric reheat to get the space temperature right. So there's a lot of these commercial systems out there that are much prettier than ours, but I don't think there's one any cheaper than ours. Ours is about as low cut as you get. I think we have to buy hardware for every building, and I think it costs us anywhere from $1,000 to $3,000, depending on what types of energy are in the building for each building to fit it up with the hardware that we need. But once we make that investment, it just goes on. Yes, sir?
What size of a building is that you're talking about?
It's independent of the size of the building. It's really about, but our typical size is 100,000 square feet. But the cost is totally independent. It's just the types of energy. Like, for instance, if it has chilled water that we want to measure, that's the most expensive thing we have that we can measure. Electric only costs us $1,000 or something to set that up. But just a flow meter alone for chilled water can be $2,000 or $3,000 just for the flow meter, just one part of it. So that really drives up the cost. But the front end, the stuff that we made is completely free. We use all open source product. It's all the data stored in a SQL database. It's updated every 5 minutes. So each 5 minutes, our server goes out on campus and hits every one of the meters, every building, and multiple meters, and it reads the energy consumption, stores it away in a SQL database, and then we can